Okay, so we're going to have a look at how to find the volume of a cone. So this is the first question from the worksheet that I set. So reading question 1, work out the volume of each of the following cones. Give your answer to one decimal place. So I've just drawn a picture of the very first cone. So the cone is kind of sat on its base with its point going upwards. We've got a measurement going up and we've got this little measurement down here. Now a cone has a circular base. Now if I were to just draw what could potentially be the base of the cone, which is a very dodgy looking circle there. So imagine we're looking at the base from either the bottom or the top, then that's 7 centimeters. Seems to go halfway across that circle. Now a measurement that goes halfway across the circle is called the radius. And for us, our radius is 7 centimeters. If we're given a measurement that goes all the way across the circle, this would be called the diameter. Now for us, if 7 centimeters goes halfway across, then the diameter for us, if we were given it, if we needed it, would be twice that, which would be 14 centimeters. But we don't need to worry about that. We're given the radius, and in fact that's the information that we need for this question. If we were given a diameter instead, we need to work out what the radius is from that. This rule involves the radius because r is part of the formula. R is short for radius. So we definitely need to use it. So getting back to the actual problem then. So the rule for the volume of a cone is 1/3 pi r squared h. Now, when you have everything put together like this in a little algebraic rule, it's always timesing together. Whenever things are next to each other in algebra, they're always timesing together. So another way of writing this rule would be like what I've written here. So 1/3 times pi times r squared times h. Now we've already mentioned that the r represents the radius. You might be able to hazard a guess what the h may stand for, because we are also given that in our problem, and that is the height. So for us, we have got a radius of 7 centimeters and we've got a height of 20 centimeters. So all we need to do, because we are allowed to use the calculator for all the problems that I've set you, we are going to put these numbers into the rule, and this is our rule every single time for the volume of a cone. So before we use the calculator, I'm just going to write down what I'm going to put into the calculator. So for my answer then, to find the volume, I'm just going to write down V for volume, just to keep it a bit shorter. We're going to put 1/3 times pi is a special number. We can find on the calculator it's about 3.14 and it keeps on going. The reason why pi is involved is because we've got a circle involved with our rule. So whenever circles are involved with like area and volume, you'll no doubt see the pi symbol, and our calculator has pi on it, so we're good to go with that. And then we've got times r squared. And remember, for us, r is equal to 7 centimeters. So instead of r squared, I'm going to put 7 squared. And then we've got times r, and for us, times h, and for us, h, the height, is equal to 20. So instead of times h, I'm going to put times 20. So I've written out the full rule, but I've substituted the letters with their appropriate numbers for this particular question. So now I've got down what I'm going to type into the calculator. So now let's actually work that out. Now your calculators are going to be a little bit different to mine, but they're very, very similar looking, with a few little differences. So the first thing I need to do is I need to put 1/3 into the calculator. So you should have a fraction button on your calculator. So if you press that first, I'm then going to put 1/3 in. And then I'm going to move out of that fraction using the little dial at the top. I'm now going to put times, And then the pi symbol is actually, it's the little yellow symbol above the very bottom button in your calculator in the middle. So I need to press shift to get to that. So shift and then the button to give us pi. I've then got times 7 squared, so I'm going to put times 7, and then you've got a choice. You can either press the squared button, which is this one just above my finger now, or you can actually press this button here, which allows you to put any power you like. So if you wanted to put a power of 2, a power of 3, a power of 4, anything like that, you can press this button. But I'm just going to press the squared button, so you can see the squared appear, and then I'm going to put times again, and then finally I've got 20. So I've put it all in, let the calculator do all the hard work, press equals, and the first answer that comes up is an answer involving pi. So anything involving the symbol pi is no doubt going to give us quite a complicated decimal. So what the calculator does gives us an easier way of writing the answer, leaving the pi symbol alone. So I'm actually going to write this down first. So we've got 980 over 3 times pi. So this is an answer in terms of pi, but our answer needs to be to 1 decimal place. So we actually need to turn this into a decimal. So I'm going to press the SD button on the calculator. And if we have a look at that, so I'm going to write down the full number first. So we have got 1026.2536. Okay, so that's the full decimal that I've been given on my calculator. Just going to move that out of the way now. And before I leave it, I now need to round it to 1 decimal place. So find where your first decimal place is. That's the point where we need to do our rounding. If the next number is 5 or more, which it is, then this 2 has got to get rounded up. Otherwise, it's going to stay as a 2. So that 2 is going to get rounded up. So that 2 is going to become a 3. And I've now got my answer to 1 decimal place, 1026.3. The last thing we need to do is put our units on. So we've been using centimetres, so centimetres is going to go at the end. If it was area we were working out, it would be centimetres squared, but because it was volume, it's going to be centimetres cubed. And that is our final answer.